Somewhere in a cold Siberian cave, scientists found a piece of ancient human small enough to sit in the palm of your hand. A single finger bone. That's it. And it rewrote what we thought we knew about our own history. The cave is called Denisova, tucked into the Altai Mountains, a region that had already produced Neanderthal remains and modern human artifacts over decades of excavation. Researchers had catalogued thousands of bone fragments from that site, most of them unremarkable animal remains, chipped stone tools, and scattered charcoal from ancient fires. This particular fragment, catalogued almost as an afterthought alongside piles of similarly unassuming bone chips, ended up being one of the most important discoveries in the history of paleoanthropology. When researchers extracted DNA from that fragment, the results didn't match anything on file. Not Neanderthals, not us, not any known group of ancient humans. It was something else entirely, a whole branch of the human family tree that had been sitting in our genetic code the entire time, completely unnoticed. Scientists named them the Denisovans, after the cave where that first bone turned up. And since that discovery, almost nothing else has surfaced. A few teeth. A jaw fragment found high on the Tibetan plateau. That's essentially the entire physical record of these ancient humans. You could fit every known Denisovan fossil on a single small table. Compare that to almost any other group of ancient humans we study. Neanderthal sites alone have produced hundreds of skeletal remains, entire burial contexts, tools numbering in the thousands. The Denisovans have handed us a finger bone, a few teeth, and a piece of jaw. And somehow that's enough for scientists to say with confidence that an entire distinct population of ancient humans lived, thrived, and eventually disappeared. Here's what makes this so strange. Most ancient humans we study, we know from skulls, skeletons, tools, sometimes even living sites. The Denisovans left behind almost none of that. If DNA sequencing hadn't existed, we might never have known this group of ancient humans existed at all. They would have stayed permanently invisible, erased from history, simply because the physical evidence never survived long enough for anyone to find it. And yet, their genetic footprint is massive. Some populations in Melanesia and parts of Asia carry Denisovan ancestry, with certain groups showing as much as 6% of their DNA tracing back to these ancient humans. That number might sound small until you realize 6% of your entire genetic blueprint coming from a species we've only ever confirmed through a handful of bone. Fragments is, by any measure, an enormous amount. Tibetans specifically inherited a gene called EPAS1 from them, a gene that lets their bodies use oxygen efficiently at altitudes that would leave most people struggling to breathe. Think about that for a second. A group of ancient humans we can barely find in the ground is actively keeping people alive today, on mountains most of us couldn't survive on. The EPA's one gene works by regulating how the body responds to low oxygen levels, essentially preventing the kind of dangerous overproduction of red blood cells that happens when lowland humans try to live permanently at extreme altitude. Most people who move to high elevation develop thicker blood over time as a stopgap response, which sounds helpful, but actually raises the risk of heart problems and stroke. Tibetans carrying this Denisovan gene sidestep that entire problem. Their bodies simply handle thin air more efficiently from birth, a solution these ancient humans apparently perfected long before anyone else needed it. And Tibetans aren't the only ones carrying pieces of these ancient humans forward. Papua New Guinea and parts of Australia show some of the highest known percentages of Denisovan ancestry on the planet. Some researchers have even found evidence suggesting there may have been more than one distinct Denisovan population, genetically different from each other, interbreeding with different groups of modern humans in different regions at different points in time. If that holds up, it means the story of these ancient humans is even more complicated than a single lost tribe in a Siberian cave. So what happened to them? As a living population, the Denisovans appear to have faded out somewhere around 30,000 years ago. Their range might have stretched across a huge portion of Asia, but their numbers were likely thin and scattered. And thin, scattered populations rarely hold on once the environment starts shifting beneath them, competing with other ancient humans for the same resources, the same territory. There's one detail that makes this story even stranger. In that same Denisova cave, researchers found the remains of a young girl whose DNA revealed something nobody expected. Her mother was Neanderthal, and her father was Denisovan. Two distinct groups of ancient humans, different enough to be classified as separate branches of humanity, had children together, and we have direct physical proof of it from a single bone fragment. It suggests these different populations of ancient humans weren't just aware of each other. They were close enough, often enough, for that kind of overlap to actually happen and leave a trace. What's fascinating is how much this flips the usual narrative. We tend to think extinction requires something dramatic, a catastrophe, a war, a single defining event. But these ancient humans suggest something quieter. A population can simply become too small, too spread out, too disconnected, until one day there just aren't enough of them left to continue. It also raises an uncomfortable question about how much of human history we're actually missing. If an entire branch of ancient humans could stay completely hidden until a single finger bone happened to survive, get discovered and get sequenced with technology that didn't even exist 20 years ago, what else is still buried out there? Some researchers suspect there may be other undiscovered groups of ancient humans whose genetic traces are sitting in modern populations right now, simply waiting for someone to notice a pattern in the DNA that doesn't match anything we've catalogued yet. The Denisovans remind us that entire chapters of human history can vanish almost completely and still leave fingerprints in the DNA of people walking around right now. You might be carrying a piece of them without ever knowing it. Every time genome sequencing becomes cheaper and more widespread, scientists uncover another sliver of ancestry that doesn't fit neatly into the story we thought we already understood. The finger bone from Denisova Cave wasn't the end of the mystery. It was just the first thread anyone managed to pull. If a species we can barely find blew your mind, hit like. Comment below whether you think there are more ancient humans out there we haven't discovered yet. And subscribe, because next time we're heading to a remote island where an entirely different group of ancient humans evolved into something you genuinely won't believe.